So as you can see here, I have my scope running with all 4 channels hooked up to the 4 LEDs on my prototype. I have a Cortex M4 here, runs at 100 megahertz, got a mega flash, like 256K of SRAM. I have a yellow, green, red, and a blue LED. It just happens by coincidence that my trace colors match the LEDs. I have 2 UARTs here, and they're hooked up and being run on the screen. One is UART 1 and it prints out a 1, and the other one is UART 6 and it prints out a 6, and you can see those in the 2 consoles to the lower right. This is an EEPROM, 256 byte EEPROM, or is it 256K? I don't remember right now. I'm a little tired. And then 1 megabit data flash. This runs over SPI, this runs over ITC. So I've got my Segra probe there, and this is running NUFR RTOS, written by a friend of mine. I helped him out a little bit here and there, but you know, he predominantly wrote it. I'm using Ozone, the debugger, and I'll build it from scratch here in this console window. And you can see all the peripherals being built, the RTOS code, all my code, everything's being built. Generated a brand new image, and I'm going to go ahead and load that image. And what you'll see is down here in the terminal, it'll print out information about what's going on, and then I'm just going to run it, and you'll see a bunch of messages here printing out. And then the LEDs, you can see, are blinking, and UART 1 is printing a 1, UART 6 is printing a 6. The scope is measuring that, and you probably can't read that on the video, but it says it's 1 hertz frequency. It's on and off 1 hertz, so that's actually what it's programmed for. It's 1.02 hertz. And the low, the high are identical, and there's no delta, there's no sigma, there's no fluctuation really in the signal, which is amazing. As you can see in the window in Ozone, the embedded instrument trace macrocell is spitting out what messages are being received by the I/O task, and those messages being received are actually driving the UARTs and the LEDs. So you know, this is pretty simple app. It's not really doing anything. This prototype I'm going to shrink down, and it's going to be a single module. You know, the data flash, the EEPROM, and then the ARM controller are going to be on a chip, you know, or a board maybe 2 inches by 2 inches when I get it all straightened out and done. And then that can go into other things that I want to build, like you know, a power supply if I want to build another one, or a data logger, or you know, a motion control system for something, or whatever. It doesn't matter. I'll have, you know, a meg of onboard code space, a whole entire meg of off-board off-chip storage, and then configuration in an EEPROM as well, and the ability to have multiple pins broken out. By no means are all the pins broken out and used for what's going on here. I also have, I forgot to mention, I have master clock out 1 and master clock out 2 configured to go out there as well. So if I want to, I can monitor what master clock output signal is going on. I could also use those on another board that's hooked up to this module to drive a clock for something else. I could down clock the master clock out signal and use that to drive a clocking circuit, like yeah, you know, to clean up the signal, like a 7400 series logic chip or something to clean it up and drive it, or a Schmidt trigger or something to clean it up. But yeah, so this is what I've been working on, the prototype hardware and then firmware to run all of this. So Yep. See you next time.